But getting back to the code here, the hopeful benefit of this example is that I show how to use zipWithIndex right there, and then I show how to use map to transform each one of these tuples that comes out of here, these tuple values that I show right here. And then I use map to show how to transform that into this string over here. And then we do take again. And also the new addition was run for each down here. So there's several things that are different in this example. Okay, now coming down to the next one, I'm going to get into a little bit of error handling. So again, I start with the Fibonacci stream and I call map on each element. So we say for every element, if, I don't know why I use that, if n is greater than 100, I want to fail right there. Otherwise, I want to succeed. And again, that happens when n is greater than 100. Okay, I just made some changes to example number 7. For some reason, I liked it when I created it, and when I looked at it just now, I'm not a huge fan of it. I really kind of overcomplicated some things. So I will go through this, but I'm just going to kind of go through it quickly. My initial intent was to show something like catchAll, and I've shown that in previous videos, so it's not really necessary to go through this, but it is here, so okay, I'll go through it. We start off with the stream, then we're going to call map here. And what I'm doing with map is I'm transforming this integer, and I'm saying, if n is greater than 100, then return a ZIO.fail. So this part here is going to end up in the error channel right there. And otherwise, if n is less than 100, then go ahead and return a ZIO.succeed, and that's going to be a success value. But notice that these aren't just values, they're actually effects. So as I put in the comment here, map is transforming each number, each Fibonacci number, into either a success or a failure effect, with a real emphasis on the effect because of the ZIO.succeed and the ZIO fail right there. Then what I'm doing here is showing flattenZIO. So this is the part I'm kind of hoping that if you ever run into this situation in the future, you'll see, oh, I can use flattenZIO to fix this problem. So what's coming out of this map right here is a Z string with any and nothing. And then the success value here is a little bit different. It's a ZIO type inside the success value right here. So what flattenZIO is doing is it's flattening that Z string right there into this one right here. So it's taking the string error type here and putting that here, and it takes the big int success type here and puts it here. I don't know how often developers use flattenZIO, but I was trying to create a catch-all example and ended up with this code, and I thought it was worth sharing. But an important part is that flattenZIO executes each ZIO effect in the stream. So again, map is transforming an integer into a ZIO effect, either this fail one right here or this succeed one right here. Then when you come into flattenZIO, what's going on is it's executing those effects in the stream. And if it succeeds, the result is the big int here. And if it fails, the failure string is what ends up in the error channel right here. So that's how we end up going from this type here down to this simpler type that we're used to seeing. Again, the key is that flattenZIO executes the ZIO effect, and then we get these two possible results. And that's what gives us this type signature in the end. So now at this point, at the end of flattenZIO, we're working with the Z stream there that I have highlighted. And now we can go down to the usual catch-all that you've seen before. So I should mention that if flattenZIO succeeds with big int, the code is going to go right through this line. But if it fails with a string, that's where we do the catch-all. And then this error right here is going to be a string. And that's going to come into the Z stream succeed. And we're going to have this string right here inside of this Z stream succeed right there. So again, I feel like I need to emphasize that if flattenZIO succeeds and we have a big int success value, catch-all right here is not called at all. The code just goes on to the take line right there. But if catch-all produces a string error, that is when it does run and this code is executed right there. So as I think about it, maybe there is some value in showing you how flattenZIO works here, as I just described. I'm not going to go through all that again, but I just described that there. So now I can run Scala CLI, and this is still 200, and go ahead and run that. You see all the success results, and then once the value gets over 100, we have the error message right there. Caught that value too large right there. Okay, so that is that example, and I hope there was a little bit of value in there. And finally, we have number 8 down here. So give me just a moment. Let's do that. Okay, and now we're going to compose multiple streams. So this one is kind of cool, I hope. So you can see that inside the run value, we have another for expression. We start by printing starting stream composition. So what we're doing here is we're creating an even stream from the Fibonacci stream. Then we're going to create an odd stream from the Fibonacci stream. And then we're going to merge the even stream and the odd stream, and then tap that stream to produce this merge result output. And you can see runDrain at the bottom of this merge right here. So again, we are inside of a for expression, and maybe I should improve the formatting here a little bit so you could see that. Okay, I want to fix the alignment in this code so you could see what was really going on. Because again, we're inside of a for expression. So we do that first print line right there. We don't care about the return value there. Then we say the even stream is equal to the Fibonacci stream. We filter or retain all the even values. So I'm tapping that even stream and printing those out. Those will come out over here. And I'll take 5 of these as we're going along. And then we have the odd stream. The biggest difference there is that this is not equal to 0, where that one is equal to 0. We tap that again, say odd stream, and take 5. And then in the very end of our for expression, we have the even stream. And then we say we want to merge this even stream, which again is a Z stream right there. And this one is also a Z stream right there. So we're saying I want to merge those two streams. And then once you do that, I want to tap that and then print out the merged result over here. And then here we do the runDrain at the end of this even stream. So that's kind of a nice key point to show right there, is where the runDrain needs to be in something like this when you're composing multiple streams. Let me go ahead and save that and then come over here and we can run that again. So then we have the results, and you can see even stream is printing out 0, and then we have the merged result is 0. So for the value 0 in the stream, we're getting these 2 lines of code right here. And then when the next value from our Fibonacci sequence is 1, we get that result. The next value in the Fibonacci sequence is again 1, so we get that result. Then once we add 1 and 1 in the Fibonacci sequence, now we get the 2. So now you can see that we will be alternating the even stream and the merge result. And then we'll have the odd stream merge result for 3. Then the next number in the Fibonacci sequence is 5, so that one's odd, and so on. And the key as we're going through this is you can see that we're only getting even stream printed or odd stream. We're not getting output for both this one and this one at the same time. We're just getting this one or this one here, and we're always getting the merged result there at the end. So I hope this is a decent example of showing how you can use an infinite stream source, like our Fibonacci stream, and then filter those results to create these 2 streams, and then merge those 2 streams together like we're doing right here. And that's the end of these examples. So if I go back up here to the documentation, you could see the 8 different examples we have here. That first one, again, the 0th value right here is just how to create an infinite stream with rate limiting. And that was creating our Fibonacci stream right here. And I talked about that way early on in this video. And then we have the 8 examples that I just went through right there. So I'm not going to go through describing all of these again, but go ahead and take a look at the GitHub repository, find file number 200, as you see right there. Check that code out and work with these examples and modify them however you want until you completely understand how they work. And as always, I hope this video has been helpful.